So in this video, we're going to revisit motion with vectors. And we've talked about this before, but it was back when we only knew about differentiating. We hadn't discussed integrating or antiderivatives yet. So to refresh your memory, we could have a position vector, x of t, y of t. The derivative of each component gives us a velocity vector. If I take the derivative of each component of my velocity vector, in other words, the second derivative of each component of the position vector, gives me an acceleration vector. But then with speed, remember that speed is the magnitude of our velocity vector. It's how long is the velocity vector and removing the idea of a direction from it. So that's a scalar, not a vector. Remember, scalars are just numbers, whereas vectors have components to them. So to find the speed, we have to find the length of the velocity vector. And since it's in 2 dimensions, that's really the Pythagorean theorem on our velocity vector to see how long it is. Now, because we've learned integration now and anti-differentiation, we could do these all backwards. So if we were given an acceleration vector and initial velocity, we could find the velocity vector. If we were given velocity vector and an initial position, we could find position vector. What I want to add that's a little bit new is displacement and distance given a velocity vector. So for the sake of ease in writing and typing, I'm tweaking how I'm writing my velocity vector here, in that I'm writing my velocity vector as Vx. The x component is V sub x, the y component is V sub y, and of course with respect to time. So the displacement is the change in position. So I do that by going ahead and taking the derivative, or the integrals, of each component. Whereas distance is the magnet is, and I can think of displacement as I'm accumulating the velocities. Because if I accumulate the rate of change, I get the amount of change. And since displacement is the change in position, if I accumulate the rate of change of position, I get the amount of change. Whereas distance is accumulating speed. And if I accumulate speed, that means I'm doing the integral of how I find speed in vector form. So how this can get used. Let's say I have a particle where my velocity vector has an x component of t minus 3 pi cosine pi t, and a y component of 2t minus pi sine pi t. And the particle at time 0 is at the point 1,5. And I want to find the position at time equal 4. Well, I know it's starting at 1,5. That's important for me. And I'm told the velocity, so from velocity, I can accumulate velocity to get the displacement. So my displacement would be the integral from 0 to 4 of the x component of velocity and the integral from 0 to 4 of the y component of velocity. I could do these by hand, but for the sake of time, I'm just doing this on my calculator. I get that this is going to be 8/16. But that's not where I'm ending up. That's the change in position. From wherever I started, this is saying over the time of 0 to 4, I moved from wherever I started 8 units right, 16 units up. So this is where my starting position comes in. So my position at t equals 4 is my starting position at 1,5 plus my displacement 8/16, which gives me an ending position at 9/21. If it helps to think of it this way, this is the FTC with a twist. Where I end up is where I started, plus the accumulation of my rate of change. But because it's a vector, I have both an x component and a y component. Then, if I want to find the distance traveled, because the displacement of 816 is not the distance traveling, because we're moving back and forth. We're moving around the coordinate plane here, not linearly in one direction the entire time. So if I want to find the distance traveled from 0 to 4, I need to accumulate the speed from 0 to 4, which means I'm doing the integral from 0 to 4. It's going to be a really ugly radical. I take the x component of velocity squared plus the y component of velocity squared, add them together and put inside of a radical, a square root, do the integral from 0 to 4 with respect to time on that. And this one I definitely need the calculator for. I get 33.533 is the distance traveled.